For this next function, we're going to do the same thing we did in that last video, but this one's going to take a little bit more work because it has a higher degree. Okay, so we're still doing these steps whenever we go through this example. So the first thing that we're asked to do is discuss the end behavior. This is a fourth degree with a positive leading coefficient, so it does something like that, which means up on the left and up on the right. That's the summary. But if we write it using algebra and arrow notation, as x gets smaller, so as x goes to negative infinity, y gets bigger. As x gets smaller, y gets bigger. And as x goes to the right, y goes up. So as x gets bigger, y also gets bigger. This is the end behavior that we'll be looking for. The next thing is to find all the rational zeros. Finding all the rational zeros means find all your p's and q's. So 10 is your p, 1 is your q. We need factors of each, so factors of 10 would be positive and negative, 1, 2, 5, and 10. Factors of 1 would be positive and negative 1. Put all your p's over all your q's. If you put all these over 1, you just get all these. So you have 1, 2, 5, and 10. This is your list of possible rational zeros. Alright, what is C? Write the polynomial in factored form. That means we have to start testing our zeros. Let's try p of 1 and see what happens. So we do 1 stow x enter and type in our function. Just gonna double check. Okay. We get 24. That doesn't work. Let's try negative 1. Recall the function. We get negative 12. That doesn't work. So we'll move on to our 2 next. Let's try p of 2. That's 12. That doesn't work. So let's try p of negative 2. That's 0. We stop and do synthetic division. Negative 2 goes on the outside. See if you're missing any terms. 4, 3, 2, 1, 0. We're not, so we'll put our coefficients in. Bring the first one down and multiply. Add, multiply, add, multiply, add, multiply, add. Okay, we got a remainder of 0. That's a good thing. So remember, you always do x minus this number. Always. So your polynomial is x minus negative 2. That came from there. And then this part, we reduce this by 1, so we get x cubed, and then x squared, and then x, and that's our constant. So we are still in the process of working out our factorization. Here we have 4 terms. We try to factor by grouping, but it doesn't work. In that case, we have to do p's and q's again, but only for this part right here. So inside there, p is 5, q is 1. So p is 5. Factors of p are positive and negative 1 and 5. Q is 1. Factors of 1 are positive and negative 1. P over q would be positive and negative 1 over 1 and 5 over 1. So 1 and 5. So remember, we're only testing this part because this is already a singular factor. We just need to get this part factored. Now, here's the cool thing. If when you tested a 0 in the first set of P's and Q's, if it did not work, it won't work the next time. So we already know that 1 and -1 won't work. So let's try 5. Store 5. Remember, we're testing this part. So we type in that function. X cubed minus 7x squared plus, okay. And we get 0. So we stop and do synthetic division just with this part. 3, 2, 1, 0. So we have 1, -7, 9, 5. Bring down the 1 and multiply. Add, multiply, add, multiply, add. We got 0. That's a good thing. So right now, go back to this. We have our P of x is equal to, don't forget the x plus 2, x minus this number. So we have x minus 5, but we also have this part. So we reduce this by 1, this becomes x squared, and this becomes x. Now, we see if this will factor. Are there factors of -1 that add up to -2? And there aren't any. In a case like that, you're going to have to use the quadratic formula to break this one down a little bit farther. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So let's just start simplifying. That'll be a positive 2. That's a 4. 4 times, or -4 times 1 times -1 is a positive 4 all over 2. That's 2 plus or minus the square root of 8 over 2. Remember your little factor tree, 2 times 4, 2 times 2 times 2. 2 get to come out, but 1 stays inside. So you end up with 2 plus or minus 2 square roots of 2 over 2. And if you factor a 2 out, you can see that it does reduce down to 1 plus or minus the square root of 2. You actually just found 2 more zeros right here. So, how do we write this in completely factored form? So we're going to go to the top of the page now. So our function was x plus 2, x minus 5, and then we have these 2 zeros that we just got. 1 plus the square root of 2 and 1 minus the square root of 2. Okay? Remember, you always do x minus your zeros. So we're going to have x minus 1 plus the square root of 2, and we have x minus 1 minus the square root of 2. All I did was do x minus each of these right here. Let's simplify this. So when you distribute that negative, you end up with x minus 1 minus the square root of 2. Distribute the negative, we have x minus 1 plus the square root of 2. This is in completely factored form. The next thing we're supposed to do is find all the zeros. The cool thing is we did most of the work already. Here's a 0. Here's a 0. And here are 2 zeros. So we have them all. X is equal to -2, 5, and 1 plus or minus the square root of 2. These are all of our zeros. All of those occurred only one time, so they all have multiplicity 1, which makes them all cross points. This is a mad jumble on this piece of paper. Okay, for E, we're supposed to find the y-intercept. That means let x equal 0. If we let x equal 0, we have 0, 0, 0, 0, and a 10. So in that case, y is 10. So our y-intercept is the point 0, 10. Now remember, your zeros represent your x-intercepts that are all cross points. So let's graph these 4 points and this 1 point and use our end behavior to sketch our graph. So 0, 10, we have x equals negative 2, x equals 5. So 1 plus the square root of 2 is 2.4. and 1 minus the square root of 2 is negative 0.4. So let's graph those as well. We have 2.4, that's about here, and we have negative 0.4, which is about here. So we have 5 points on our graph. Remember your end behavior, up on the left, up on the right. So we know it's going up this direction, and we know it's going up this direction. We just have to fill in all the rest. Remember, all of these are cross points. So it does something like this. Now remember, this is not drawn to scale. This could go really, really high. These could go really, really low, or they could be little curves right there. It doesn't really matter to me as long as I know you know the basic shape and you get these 5 points on your graph.